So once you've got a good image, it's time to add some tools and do some programming. So because we want to find this mem plus care pattern here, let's use a pattern tool. So let's go to locate part, pattern, add. Now I place the model box over the pattern that we want to train, the pattern we want to find in subsequent inspections. Let's click OK and let the tool initialize. So there, it's initialized. You can see with this green cross here. You can also see it with this model region, so all these blue lines are edges, because that's what the model region looks for, or that's what the pattern tool looks for. It looks for edges, and tries to match the edges here with the edges seen in the image here. We've also got the rotation tolerance, which I'm going to turn down to 10 degrees, because this is a orientation inspection, so I don't want my parts to be rotated. The part finding meter is a measure of what your tolerance is for how similar the image here, the edges here, match the edges in the model region. If there's a good match, then the result's a pass. If it's a bad match, the result is a fail. Right. Another thing to look for is this inspection time. Let me just, there, that's better. Trigger inspection. So the execution time here for the tool, the execution time for the entire job. And this is important because if this is slower than your cycle time for your process, then it will start missing inspections. So you always want to make sure that this is faster than your cycle time. And if you have trouble getting to that, you probably need to use a camera with more processing power to drive this down, or look at all the tools that you have. So I'm just going to test this, see how it goes. So there, I can move it around. Oh, rotate it too much and it failed. Now I was just catching it on another orientation. Nothing. Exactly what we want. This fails. Turn it over sideways. Fails again. Fails. So I'd say this is a complete inspection. Everything's complete. So since we got that down, we need to get the camera talking to other pieces of machinery. One way we do that is using discrete outputs. And discrete outputs are just on-off pulses sent down its individual wire, kind of like a switch. So I can set it up for a job pass and a job fail just by using the signal type and job results columns. I can also do this with industrial Ethernet. So for that I go to communication. There we go. I've already set up a Modbus TCP server. And I can go and add things, add what I want. But I've already got a job pass and a job fail. And it's in this nice chart here, which gives you all the information that you need to be able to connect this camera to a PLC using Modbus. So once you're satisfied with how it's communicating, you save the job, and save it in a way that once you stick it on a machine, it will just start running. So you go to the save job, go to save as. Let's just give it a name. There we go. I go to startup options. This is a job that is going to run when the camera starts up. Let's take the job I already have, or that we did, and click this box here to start the sensor in online mode. What this means is that once power is applied to the camera, it will just start running this inspection that we just programmed in. It'll be running this job. So you click that, and there you go. That's it. I hope you found this video useful. If you have any other questions, check out our other videos or get in contact with us through our website. and be sure to follow us on LinkedIn to stay current with the latest products.